Hi there, welcome to our science review. For this day, we're going to discuss about or review the quantum mechanical model of an atom. So remember that in the Bohr's model of atom, he revealed most of the answers to the questions about the atomic structure. And it seems that all of those were proven to be incorrect, but it provided a useful basis for building an explanation. So some physicists like Erwin Rudolph, Joseph Alexander Schrödinger, and Louis de Broglie studied the behavior of electrons, and they proposed light and atoms might exhibit the same properties. Schrödinger used a mathematical concept to come up with a new model for the hydrogen atom, which may be applicable to other atoms, known as the quantum mechanical model. And this is what it looks like, exactly what the quantum mechanical model is. In 1901 to 1976, Werner Heisenberg formulated his uncertainty principle, which states that it is impossible to determine both the momentum and the position of an electron at the same time accurately. So meaning to say, it is really hard to determine its position and the momentum of those electrons. But in these principles, it affirms that as the electrons move in a greater speed, their exact location cannot be determined, but the probability of finding the electron around the nucleus can be predicted. So these rapidly orbiting electrons can be presented by electron clouds. And this is what it looks like. The electron clouds, the probability wherein electrons can be found there. So therefore, the location of the electron depends on the energy it has. Normally, exists in the lowest energy, we call it the ground state. When the substance is strongly heated, the atoms absorb this energy, and the electrons receive it becomes excited. So we can call it now in the excited state. Valence shell got the highest occupied energy level as it is the last orbital. And the electron found in this valence shell is called the valence electron or electrons. Valence electrons are important in determining the atom may be reacting chemically with another atoms. A closed shell happens when the atoms with valence electrons tend to be stable, like the neon. Atoms are highly reactive when they have one or two more valence electrons than a closed shell. And atoms with one or two fewer valence electrons than a closed shell are also highly reactive because of the tendency either to gain the missing electrons and form negative ions, or to share electrons with another atom, like sodium chloride. So Bohr's model, as discussed in the previous topics, was limited only with hydrogen atom with one electron. He predicted that the energy levels of atoms larger than hydrogen atom could hold a certain number of electrons at a time. He was able to predict the maximum number of electrons a particular energy level will have. Example, first orbit may only hold 2 electrons, that's the maximum number. The second orbital can hold 8, the third is 18, and the fourth is 32, like in this example. So I hope you learned something from our review. See you again on our next discussion. Bye-bye.